In this lesson, we're going to talk about texture wrapping. Texture wrapping is what happens when vertices specify texture coordinates that are outside of the normal range of 0 to 1. And here's the texture that we're going to be using for this demo. So this is the cover of our live lessons, and normally you'll see this mapped like this. Now, I know I mentioned that 0, 0 was in the lower left-hand corner, but the way that the soil library works is that the memory is going to be mapped such that the 0, 0 is actually going to be in the upper left-hand corner, and 1, 1 will be in the lower right-hand corner. So normally, V0, if I specify this as 0, 1, this means that I'm running vertically from the top down, 0 to 1 along the vertical, and from 0 to 1 along the horizontal. Now, the interpolator finds the in-between point, so 0.5 on the U, 0.5 on the V, so the interpolators would find the in-between texture coordinates. So now what we're going to do with texture mapping is we're going to specify texture coordinates outside of this normal range. For example, in this image you see that we specify the same vertices, so V0, V1, V2, and V3, so a quadrilateral with 4 vertices. But this time we run from 0, 0 to 3, 3 in the lower right-hand corner. So now what happens actually is in between these vertices, the interpolated UV are going to run from 0 to 1, right? So this will be 1, 0, this will be 2, 0, and this will finally be 3, 0. And similarly, on the vertical, this will be 0, 1, 0, 2, and 0, 3, all the way down to 3, 3 in the lower right-hand corner. This is all data that comes from the interpolator. So the question is, what happens when we have a quadrilateral that has UVs that go beyond these boundaries, as you see here? In this case, we've got 3 divisions, both horizontally and vertically. And that's what texture wrapping modes are all about. Let's hop back into Visual Studio. In Visual Studio, we've got our wrapping modes demo. And our wrapping modes demo specifies an enumeration called wrapping mode. And this is just my own little twist on this because we're going to allow us to iterate and walk through the different wrapping modes just for demonstration purposes. So we have a variety of wrapping modes that are supported in OpenGL. The first that we'll talk about is repeat. The wrapping mode repeat, what it does is on every one of those integer boundaries where we're between 0 and 1. When we go beyond the value 1 or below the value 0, we wrap around to the other side, so to speak. So for example, if the value is 2 on the V, then we wrap that around and it becomes the value 1 again. If our value is 1.5, our actual value is going to be 0.5. If our value is 1.1, then the wrapping mode repeat says now we're going to subtract 1 from that. The value is going to be 0.1. Wrapping mode mirrored repeat is very similar. It repeats the texture at those integer boundaries, but instead of it just repeating it over and over again, it mirrors it each time it repeats. Now clamp to edge does not repeat. Clamp to edge says, well, whenever we've got a UV that is outside of the 0 to 1 boundary, we're going to stop it, and whatever the last color that we sampled at the value 1, or if it was a negative UV at at the value 0, that's what the color is going to be. Clamp to border is similar, except that instead of specifying that the last pixel, the pixel at value 1 or the pixel at value 0 that it sampled, we're going to specify a solid color, a border color, to surround the texture. Now the rest of this code looks very similar to the last example, with the exception of these few new data members. This list of texture samplers is a set of unsigned ints. The unsigned ints, these are names for texture samplers that we're going to generate and then pass to our OpenGL pipeline. And then this wrapping mode key for this map refers to one of these names, one of these texture sampler names, so that I can index very easily into this list and pull out by name, by enumeration, a particular sampler. And this is really just a bit of secret sauce that allows us to iterate through these very rapidly. Okay. Now inside of the wrapping modes demo implementation, you'll see that we've loaded our vertex and fragment shaders just as we had in the past. Now, these vertex and fragment shaders are identical to the previous vertex and fragment shaders. Notice that we're still accepting position and texture coordinates, we're still transforming our position by the worldview projection matrix, and we're passing through the texture coordinate. Similarly, the fragment shader, right, does the same stuff that we did before, and we're going to see now where this binding equals 0 layout specifier comes into play. We sample it through the color texture sampler, and we had just accepted defaults for the texture sampler in the past. Now we're actually going to specify some properties on our own within the OpenGL C++ code. All right, instead of loading our vertices from a model, this time we're going to specify a quadrilateral manually. This set of data, and you can see the 021 and 032, this set of data mimics the image that you just saw up on the screen. So 0, 0, 3, 3, 0, 0 being in vertex 1, all right? So 0, 0 in vertex 1, 3, 3 being in vertex 3, okay? And so on. So 0, 2, 1, 0, 3, 2, those are the indices to specify the two triangles within our quadrilateral. We create our index and vertex buffers just as we had in the past. Our creating vertex buffer this time around looks like it did earlier on, where we weren't specifying it from a model, from a mesh specifically. So we're just populating the buffer with GeoBuffer data, the call to GeoBuffer data for a GL static draw call. Now what we're going to do is specify all of the various sampling modes that we're going to demonstrate here today. That's specifically done through the GL sampler parameter I command, and we want to pass in a particular parameter. And the two parameters that we care about are GL texture wrap S, GL texture wrap T. And note that in OpenGL, the terms UV are synonymous with S and T. So S being horizontal, T being vertical. And what the third argument is GL repeat. So that third argument specifies this is the value of the sampler parameter for wrap S, and this is the value for the sampler parameter for wrap T. And of course, these can commingle. We don't have to have the same parameter specified for both S and T. So what we're doing here is simply setting up with GL sample parameter I the GL repeat mode for the enumeration mapping mode repeat associated with the texture samplers that we've just created through this code. We created a set of names using GL gen samplers. The same sort of code now that you've seen, we've done GL gen for a variety of things. GL gen for the vertex buffers, for example, GL gen buffers. So we pass in the number of samplers that we want to get out, that we want to generate, and there's the array to vector of names that we're going to actually store the names in. So all this code is doing is giving a specific parameters to the given texture samplers associated with a particular enumeration. So for mode repeat, it's GL repeat. For mode mirrored repeat, specify S and T as GL mirrored repeat. Clamp to edge, clamp to border, and notice that this time around with clamp to border, not only are we specifying the parameters GL texture wrap S and T, but we're also specifying GL texture border color. That enumeration is not an integer. Instead, it's a vector of floating point values, and our floating point values we're going to grab from color helper, from the static purple, the constant purple member, and that's just a vec4 that has ones for the red and blue channels to make a purple color. The rest of this code is as we've had before. Same code. The on-key handler is just a little bit different. This time, instead of pressing the space key and toggling between textures, we're toggling between wrap modes. So all we're doing here is incrementing the active wrap mode, and if it gets to the end of the wrap mode, then we just go back to the first wrap mode. So now let's take a look at the draw call. Inside the draw call, we bind our vertex array objects, bind our vertex buffer and index buffers, and the color texture. But this time around, the new call that we care about is GL bind sampler. And notice that the first argument to GL bind sampler is an index that matches the binding index that we specified here inside of the fragment shader. So that 0, that's this 0. Right? And of course, we could have used an enumeration for that as well. And what I'm specifying here, using the value that's stored in the map at this given enumeration, is the specific texture sampler. So it's one of these texture samplers, and it's that texture sampler that's associated with a wrapping mode enumeration. So whatever our active wrapping mode is, that's the sampler that we're going to bind. The rest of the draw call is identical. Let's see what this does. So the first active sampler is the GL repeat sampler. And notice then that on those integer boundaries, we repeat that same texture over and over again. Normally, this would just map to the entire screen. If the values were 0, 0 and 1, 1, then the OpenGL Essentials cover texture there would just wrap to the entire screen. But as it is, we've specified that these map 3 along the horizontal and 3 along the vertical. So this is 0, 0, 1, 0, 2, 0, and 3, 0, and then 3, 3 down on the lower right-hand corner. So we map both horizontally and vertically. If we look at mirrored repeat, so the mirrored repeat does exactly the same thing, but this time, instead of on the integer boundary simply repeating, it mirrors the image and repeats it. Notice that this happens on the vertical as well. The next is GL clamp and GL clamp to edge. GL clamp to edge, notice then that what it does for every single pixel that is passed outside of the normal 0 to 1 range, it takes whatever the last pixel was that was sampled, and it replicates that from that point forward. This is true for both the S and the T, so the U and the V dimensions. And then finally, clamp to border, where we specified a border color, that purple border color. Now, there's one last thing that I want to show, and that's just as we change the vertex UV, we'll get a different output. So in this case, we're going to change if we go back here, instead of saying 00 to 30 and 00 to 33, then what we'll do is instead, I'm just going to map horizontally instead of vertically. So the V0 becomes 01. And instead of this being 30, it'll be 31. Okay. And now when we rerun this, now you'll notice that I've just removed the mirroring going outside of the edge on the vertical. So now this just wraps horizontally. And the rest of the wrapping modes apply just the same. This is clamped to edge, but now I'm just clamping horizontally because I don't go outside of the range 0 to 1 on the vertical, and likewise for clamp to border. So that is the end of our discussion on wrapping modes. Next up, we're going to talk about texture filtering.